Well, good morning again. My pleasure to introduce Dave DeWitt. Dave worked as an engineer and manager in the medical device manufacturing industry for 20 years. In 1990, he founded Timeframe Incorporated, designing, manufacturing, and selling custom products for the trophy and promotional products industries. In 2012, Dave retired and started manufacturingstories.com, a nonprofit social media effort promoting manufacturing and STEM education. Concurrently, he began working with local schools, helping with STEM awareness and education programs. That effort is now focused primarily on 3D design and printing. In addition, he has expanded his educational efforts into local libraries and daycare centers with 3D printed dinosaur parks and related curriculum. Dave holds bachelor's and master's degrees in mechanical engineering from Rensselaer Polytechnic Institute. Dave?
My pony show items here. Great to see so many familiar faces from all different times here in Peterborough and Dublin. It's nice to have my former attorney here who kept me out of tons of trouble. Knows more about me than I know about me.
You'll be speaking next.
Keep it clean, Dave. I actually need one of them myself. So,
Hey, stand in front of the computer. So that...
Oh, okay. Howdy, howdy, Zoom people. So, so the projects that I've kind of worked on to date since I retired in 2012, I sold Timeframe. Norm knows more about the sale than I do, but I assisted in setting up 3D design and printing programs with Mrs. Brezovic at her Exploring Horizons program at the middle school. And I kind of focused most of my time since I retired in trying to deal with all different types of technology and with K through 12 schools. So I haven't really gotten, involved with colleges or anything like that. I did help out a little bit when the Max was first set up, but kind of went off in a different direction with some other folks as part of the Manufacturing Extension Partnership up in Concord, and did quite a bit of work with my wonderful friend who passed away recently, Mary Lou O'Neill. She was an inspiration to the adults and kids, no question about it. I found Mrs. Brezovic she's an amazing teacher. She teaches at the middle school here in Peterborough. Her program is an elective, but I don't know how many spots she has open for next year, but she teaches, she has different aspects of her program from all the way from 5th grade to 8th grade. So you can start, I think, more or less at any point. You start at 5th, it's better off. She does things in, well, now 3D design and 3D printing. She does things in all different types of graphic arts using the Adobe Illustrator and the Adobe Creative Suite. She does all the photography, a lot of the photography for the school and the filming and videos, and she does the video things. And she also, her kids take care of the weekly presentation about what's going on at the school and so forth. She gives the kids a lot of responsibility, and they really respond. They do a lot of things. And so the 3D program started out really kind of, I can't remember exactly how she and I got started on it or how I got connected with that program with her, but it became pretty obvious for both of us that the kids really just took to it. And initially, the school didn't even have a 3D printer. So, and I only had one or two maybe at the time. But the kids were using Tinkercad. So Tinkercad, for those of you who aren't familiar with it, you should get familiar with it, by the way. It's online, tinkercad.com. It's totally free. Your kids and grandkids and stuff should really try it out. It's a much more in-depth program than a lot of people realize. It's not just for 3D design and 3D printing. There's also aspects of Tinkercad that have to do with circuit design, and circuit simulation, which is amazing, really. I didn't even know it was there for the first 2 years I used Tinkercad. I thought it was just 3D design and 3D design. And as time went on, I realized, holy cow, what's this circuit thing? And then I thought it was just 3D 3D representations of circuit components. I didn't actually realize that it had anything to do with circuits, resistors and capacitors and V equals IR and the whole thing. So they have integrated circuits there. You can build all kinds of electronic stuff. They have Arduinos, and it's all simulation. So it's all done on a computer. It's all done on, the other neat thing about Tinkercad is it runs in any browser on any computer, doesn't matter, because Tinkercad actually runs on the servers in California. It doesn't run on your computer. So you don't have to download anything to your computer. All you need is a browser, tinkercad.com, you're set to go. You have to sign up for an account. You have to be 13, but mom, dad, grandma, whatever can sign up and the kids can use it. There's nothing bad there. You don't have to worry about it. So that program is kind of off and running now. I don't interact a lot on a day-to-day basis. Initially, I printed everything that the kids designed. So they would design it. Michelle would send me the files. I printed them, brought them in. So every two or 3 days, I was down to the school dropping off all kinds of stuff that the kids got all excited about. The neat thing about 3D design and 3D printing is that it's good for both boys and girls. Each one of them has, it doesn't matter that, the boys are doing lightsabers and the girls are doing other kinds of more delicate things, let's put it that way. Little buildings and all kinds of cute little things. But it doesn't matter. And it's very challenging for both of them. The boys tend to work independently. The girls tend to work together, which is kind of an interesting thing. They do a lot of thinking and planning together, and then they actually come up with something. They're a little bit better working on projects together. The boys they talk a little bit about what they're going to do, and then they just all go off and do it independently. But I guess that's normal. But it's kind of fun. And the girls' stuff succeeds quicker. The boys go through a few more iterations because they didn't think of this or that. But at any rate, that's kind of the way I am too. So anyway, so I also set up a 3D design and printing program at the Avenue 18 Center. This was a pre-COVID thing. It turned out to be a lot of fun. I don't know how many of you know about the Avenue 18 Center. When you're going into Antrim, it's on the left in that small little group of buildings there, that the mill's on the other side of the river and the offices were on the street side. And it's the first little white section, which I think used to be one of the, I don't know exactly what they had in there, but they're in there. They do a fantastic job. Jacqueline Rowland runs that program for the Grapevine. It's part of the Grapevine. And they have programs for middle school and high school kids, mostly. I haven't been involved much with the high school programs. I've been involved mostly with the middle school program. And every Wednesday, I used to go there and do 3D design, 3D printing. And again, we started off, the kids just did the 3D design in the computers and I printed the stuff for them. By that time I think I had 4 or 5 printers at the time. So it's a lot easier to get it all done. And the thing about Tinkercad, well, CAD, I guess everybody knows, is computer aided design. And there's some big ones like, AutoCAD, which is the company that makes Tinkercad. So the gentleman who started AutoCAD decided that they needed something for kids. It was a little too complicated, to be honest with you. I'm having a hard time figuring out AutoCAD. It just, it's designed for engineers and it's got all kinds of complicated things to put things together, where Tinkercad is just kind of a drag and drop thing. And it's really easy for kids to pick up. They pick it up almost immediately. He decided that they needed something and they just called it Tinkercad. So you could tinker around in it. So, but it is free. and it's an amazing program. So at Avenue A, what we did is there was 2 or 3 students that were working with me on the design. They do some 3D design and 3D printing at Great Brook. I worked with them a little bit. I'm going to try to get back with them. COVID really messed things up for a couple of years. I couldn't get in the schools, and there's not that much you can do with this type of program if you're not hands-on. So it's a problem. You can do a certain amount, you know, via Zoom, but you can't really you can't do the one-on-one type things like, you know, and actually show the kids the stuff that's being made. So so that program now, and another thing about these programs is once you get started, there's always one student or, you know, one child that seems to really get into it. And so now the Avenue A program is being run by one of the students. One of the kids that was doing it when I was doing it, he really got good at it. Riley, he's a fantastic young man. He just seemed like somebody that wanted to take over. I had other things I wanted to do, and he took over. And as far as I know from Jacqueline, he's doing an outstanding job with the program. A lot more kids involved. It's much better to have kids run the program. I can tell you that, especially if you go in there, you know, Gregor and all that stuff. They're not sure what the heck's going to happen. So it turns out to be really good, and he's doing a great job. So I also set up a 3D capability and an adult class, which I'm just finishing next Monday. Will be the last one we're doing at the Antrim Library. And I'll put these out for you, but at the Antrim Library, I had a couple of old machines that I used to use a long time ago when we first got started. This is one of them. I donated that to the library. I donated another one to the Avenue 18 Center, so at least they have a printer. Billy asked me something about, you know, whether things that the Rotary could do to follow up on programs like this. And I can tell you, if you can help these, a lot of places don't have the money for the machines. The inexpensive ones are in the $400 range. The better ones, which you know, are in the about $1,000 range. Those are really a lot better for the schools to use if they can get them. So that's something that, I don't know, we could talk about it sometime in the future, but if there was something you folks wanted to do, I know Michelle would love to have one of the fancier machines. She's got, I think, 6 of them now, all different ranges. But so the library actually started their own program. Lori Cass is the youth librarian up there. She just took to this like crazy. So I had an old Mac computer that I donated to them, and so now they do everything in house. And that kind of brings me to the to the Dinosaur Project. So the Dinosaur Project started out. They bring one down, yeah. Well, this is mommy. So the baby's back there. Her baby's back there. But I put these dinosaur parks, and there's a picture of one on your sheet there, the double consolidated schools. So I think I've set one of these up in the Antrim and Dublin libraries, the Peterborough and Dublin elementary schools, the Conval ATC daycare center, the Monadnock daycare center, the Dublin, and the Merrimack, New Hampshire daycare center. You might wonder why I went all the way to Merrimack. Well, they had a craft show, which I wanted to go do, and they were having it at the Monadnock or at the Merrimack daycare center. And I told them if they would waive the entrance fee, I'd give them a dinosaur park. And they thought that was a great idea. So that's how that got out there. Every place where I put these dinosaur parks, the kids absolutely love them. The librarians say that the first thing the kids want to do when they get there is to go play with the dinosaurs. Now, some people would say, well, you know, blah, 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 the kids are supposed to be reading books and whatever. But the thing is, the most important thing is to get the kids to go to the library. And then there's lots of other programs at the libraries. The Peterborough Library I've approached to do it. They're just getting involved with their new building and their new programming. So I think eventually we'll get something going there. They're interested, but they just don't have the time and the staffing to actually integrate it in. And they don't like to have stuff just, basically my interpretation of what they've told me is they don't like to just have something there. They want to have something that's part of a program. So this can be made part of a program, but I think they're working on installing some other things right now, so that's fine. But in a sense, that is what happens. So the 3D, the dinosaur parks, it's just been amazing how the kids just love dinosaurs. I didn't realize kids love dinosaurs quite as much, and I didn't know a thing about dinosaurs when I started this project, other than how big they were. But the whole thing with dinosaurs is you can't be wrong. You know, when you think about it, no one knows what color they really are, and no one knows whether they actually made any noise. Your voice boxes are basically cartilage type material. It all decomposes when the dinosaurs died. Only thing that was left with the bones. There are some, so they really don't know whether they had a voice box, and if they did, where it was. They kind of guessed that they did. So all these sounds that you hear, like the sounds that you heard when you came in. By the way, this is kind of a cool thing with 3D printing. You know, you can take a modern thing like this little speaker that can play back stuff on an SD card, and you can put something around it that looks like a dinosaur rock. And don't let me down. So what I did is I went online and I found a whole bunch of dinosaur sounds. Somebody had actually taken the time to put 99 of them together in a WAV file. And I figured out how to get it onto an SD card, and bought this little other thing on Amazon, and put it all together. But they really don't know what the dinosaur sounded like. They have no clue. So, so I think that's one of the reasons why kids kind of like it, because you just can't be wrong about dinosaurs. They really like it. And it's good for kids to not be wrong. That way they try things. The whole idea of engineering is iteration. You know, try something, see if it works. If it doesn't work, how can you improve it? At least that's the kind of engineer I was. There are other engineers that can't do it that way. Like they're going to space, you can't really try it and see if it works. Right? So that's why they need people like Elon Musk, who's absolutely brilliant. But and I'm sure they do a certain amount of iterative stuff too. They can test it out other ways other than actually getting out in space. But at any rate, so there's lots of different things that, let's see, were there any other things? Oh, and then the Dublin gas engine meet. I don't know how many of you folks know Dave Lavoy. If you do know Dave Lavoy, you have to get used to working with Dave Lavoy while you're moving, because he never stops. He's always doing something. He's an amazing man. He's brilliant. But anyway, he's been involved with the gas engine show for a while. He's the one that found this design online, the general engine without the base part. But it was designed to be 3D printed. But when you 3D printed it, there was a lot of problems because it was all in one piece and nothing moved. So I took it all apart and actually redesigned it in parts that all fit together. You can't really see the parts. And then I designed the part for the bottom. And then we figured out how to make the thing. And then I went on vacation for 2 weeks and came back, and Dave has this great big engine, the one that's back there. And he said, oh, I'm going to make this big motorized thing. I said, you got to be kidding me. So I didn't even realize he's got printers like mine now. I couldn't believe he had made it. So those parts are, if it could have been bigger, it would have been bigger. I can guarantee you. That's as big as the machine would print, is the wheel. That's the biggest wheel you can print on the machine. So anyway, that's going to be there. It's going to be, I'm helping him design the holders for the engines and things like that, because all that's 3D printed, and it's all designed in Tinkercad. So just because it's a program for kids, I can tell you, I've seen stuff designed in Tinkercad blow your mind. I can't even figure, even when I take it apart, I can't figure out how anybody thought of how to do it. It's an amazing program. So what are some of the educational benefits? I don't know how long I have actually. Okay. So the educational benefits for 3D design and 3D printing, and this is for kids, it doesn't matter how old they are, is geometry and trigonometry. Everything that kids learn doing this is all by osmosis. If that's it's not really an educational word per se, but it's just, you learn stuff by doing it, you know? And so they learn about dimensions and units of measure, because if they just want to have a shape, they can just drag the shapes around. It doesn't matter how big they are. It doesn't matter how big they are till you go to print it and find out that the thing they had on their screen is bigger than the machine is, never mind being able to make it on the machine. So then we start to talk about, well, you can't make it that big. Well, how big is big? What is big? So then you have to start talking about units of measure and dimensions and things like that. So the kids have to learn that stuff. And they're not learning it because they have to learn it. They're learning it because if they want to print it, they better figure it out. So they learn it because they want to learn it, not because we want them to learn. They learn about fraction decimal conversion. When it comes to fractions, the highest fraction that most kids know is 1/8, because that's the number, that's the largest number of pieces you can cut a pizza in. So, you know, Now we need to teach them what fractions really are. And then the whole concept of a decimal equivalent of a fraction, like a half inch is 0.500, 500 thousandths. They have no clue what you're talking about. No clue. Well, I shouldn't say all of them don't, but a lot of them don't have any clue exactly what you're talking about. I mean, I'm talking about little kids that haven't learned it in school yet. So, but they don't mind learning it. And the thing that Tinkercad does is that if you have a fractional equivalent, like 0.250, which is a quarter of an inch, Tinkercad will display it as 1/4. But if you go to 0.251, it'll change it to 0.251 because there's no fractional equivalent. So they start all of a sudden saying, look at this thing. This is 1/4. When I click on it, it turns to 2.50. What the heck is that? So they start learning about decimal equivalents of fractions by osmosis. And they start learning that if they need to have it a little smaller, gee, 0.245 is smaller than 0.250. So let's try that and see how it works. And so they start learning about that type of thing. Linear and rotational measurements. Well, a lot of times if you, well, first the linear measurements are obvious. When you put it on the work plane, stuff has to be, dimensioned, and it has to be dimensioned in two ways. It has to be dimensioned because the part itself has dimensions, right? So it's an inch by an inch by an inch because it's 3D. But where is it relative to the coordinate of the work plane? So then you start talking to kids about coordinates. So now they're starting to learn about X, Y, and Z because they have to, not because we want them to. If they want to take this part and make it somewhere as near that part and then bring them together so they can coincide, they have to be able to learn about, if I change the dimension of the bottom left corner of this part to a different dimension, it moves it across the work plane and it'll run into that other thing. And then if I group them together, they become one piece. So now they start to learn about the intersection of geometrical shapes, which is a course in college that I hated, absolutely hated, because it had to do with drawing. And we used to, it was basically the concept of sheet metal. You have a round duck and how it intersects to a square duck. So if you're the guy that has to cut the hole in a square duck and it's coming into the corner of the duck, you have to figure out what's the actual area that I have to cut out so this round thing fits in this rectangular thing. Sheet metal people, just, I guess it comes naturally to them, but it didn't come naturally to me. But the more you work with Tinkercad, the more your brain starts to say, oh, if you put that and that like that and group them together, it comes out like this. This is incredible. So they start learning about those types of things. Now, rotational, if you want to rotate, they say, oh, well, this thing needs to be rotated. So now they learn the whole concept of rotating. Now, I'm not talking about older kids that already know about rotating things, but I'm talking about younger kids. They don't know how many degrees are in a circle. They don't know what the degree is. It has something to do with how hot it is. Okay, so they see the little arrow, arrows and they click on that and up here there's a little number, but it says like 5. And they 5 what? 5 degrees. Well, what's that mean? What is it relative to going all the way around? So they start, oh, if I move this all the way around to 180, it turns upside down. Huh, that must have something what is that? So they start learning about all those types of things. And it's, again, all by osmosis. They learned about computational math. They learn math all along, but they have to learn computational math because if they want to make something twice as big as something else or half as big as something else, they start finding out that if I have something that's 1 by 1 by 1, and I want one that's only half as big, I have to change it to a half by a half by a half. So they start learning about, computational things and also proportionality, percent, because there is a way in Tinkercad to talk about percent. And so they start learning about, well, what's a percent? This thing is half as big as this. So it's 50% the size. So they start learning about it, not because I wanted them to, because they have to. They learned about engineering designs and fits. One of the first things we did with myself and Michelle was had the kids make boxes to put tops on. So they make a box, right? And then they say, okay, well, if I'm going to make a top, I have to have a hole in the bottom of the top that fits right over top of the box I make. So they make the hole in the top exactly the same size as the outside of the box. That's the first thing you'd think of doing. So good. And we print it and they don't fit together because they're exactly the same size. And the printer, if it prints it just a little bit off, they're so tight, if you can't get them together, you can't get them apart. So then I say to them, so what could we do? Well, let's make the other one, either make the hole a little bigger or make the box a little smaller. Well, how small are we going to make it? So then they start to have to learn about, oh, that's the thing, 0.250, we'll make it 0.245. Maybe that'll, and then, okay, so that's 5 thousandths, but they want 5 thousandths all the way around. Well, if you want 5,000s all the way around, then it has to be 0.240, because you have to take the 0.010 and divide it in half, because it's half over here and half over here. So then they start learning all this stuff that, and after you only have to show them once, say, oh, that's how that works. Okay, we'll figure that out. So they did that. And, they learn about the fact that these two parts won't fit together. Well, what is the whole concept of fit, and what are tolerances and things like that? They learned about, well, obviously they learned creativity. They learned about colors. They learned about user requirements. The biggest thing when designing something, if you're into making retail products, is the person going to like it? Does it feel right? Is it smooth enough? Is it big enough? Does it do what I told them it was going to do? So they have to start. So what do? They talk to some other people, and they make one, they give it to them. They say, well, what do you think of this? Well, I don't like it because it feels funny, blah, blah, blah. It didn't fit in my hands. So they start learning about, you got to find out what other people think about what you're doing. You're not the only person here. They learn about how to research things, because if they're making something that's going to be used, they have to learn how to research. So they go online, and they go online as much as the school let them go online. It's really a problem, actually. But I don't know how the teachers put up with all the stuff they have to put up with, because there's an awful lot of things at the school that the kids can't do because of, it's not that it's wrong, but it's so easy for us that we don't realize how difficult it is when you can't do it. You want to know something, hey Siri, how to blah, 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 and you find out, or, whatever you say to Alexa, hey Alexa, or whatever. But the kids can't do any of that stuff in school. And it's hard a lot of times when they're online, because it's all this privacy thing. And I understand all that, but it is hard for them to do. So they have to do workarounds, and that's good for them to have to do workarounds, because we all have to work around stuff all the time. And then they have to learn how to gather data. They have to work together on a common project. Michelle is really big on that. Is that she does have independent projects for the kids to do, but she also has projects that they have to work together, because what they're going to do, you're going to make the house, you're going to make the garage, you're going to make this, you're going to make that. Well, the house, the garage, and the thing have to all be kind of the same size, otherwise it'll look ridiculous. So they have to work together, and it builds teamwork, which is almost every company now today. If you can't work in a team, you're probably not going to get the job. And then the whole idea of iterative design, which is something that I do because I have to, because I can't seem to. What's the old story? Measure twice and cut once. Yeah. Well, I was always the person that cut right away and then realized it didn't fit. So it's just the way I've been. I've been that way all along. I can't seem to break the habit. But at any rate, and my wife Judy, she's totally the opposite. So we got along really good, because I would always do some crazy thing, and then she'd figure out how we probably should have done it. But anyway, and so one of the iterative design ones that I thought was amazing, and it actually, well, it's not right for men to cry, but when I looked at it, I thought to myself, this is incredible that the student went through this. So they were making a robot, something like these moving parts that I had in the back, so, like this. They weren't doing anything this complicated, but they were doing some stuff that they wanted to make a robot, and they wanted to make the legs and the arms move. So they had to come up with a joint. Now in engineering, as an engineering manager, I used to tell engineers, they come in, they say, well, here's the project. And I used to always say to them, what's the part of the project that if it doesn't work, the whole thing is done? They'd say that. Fine, do that first. Why? That's the hardest part, right? And if it doesn't work, the rest of it's a waste of time and my money. So don't do it until you do that, right? So they would do it, and they'd probably have to do it 2 or 3 times. But once they got that fixed, then everything else worked. So the kids learned that this student figured this out on his own. This was not me or Michelle. Michelle called me up. She said, this is amazing. You have to come over and see what he did. So she sent me the thing, and I looked at it online, and I thought, oh my God, some kid did this? Holy crap. It's incredible. So, so he designed so the robot looks like a robot when it's done, but he designed, he worked on the joint first, and he did trial after trial after trial to get the joint. So when it was printed, the 2 parts would just like flex with each other. And then he connected the parts to all the other pieces. And he never put the final design of the robot's face and the stuff and all of the electronic, simulated gadgets on the robot's front and everything. He didn't do any of that until last, because that's just like the icing on the cake. He did all the complicated stuff first, and then he put all the rest of it together. And I told Michelle, I said, if that's the way that student thinks, they're going to go a long, long ways because that's the way they solve problems. They look at the thing, they say, what's the most complicated part? Let me try this out. If it doesn't work, or I got to figure out how to make that work, or the rest of it isn't going to work. So the whole idea of iterative design. And the other thing that's a big thing in manufacturing, which is my real love, is continuous improvement. You never, ever stop making it better. The minute you stop making it better, you might as well cash in your chips, you're done. Because somebody else is going to make it better tomorrow. You can be sure of that, right? And that's the American way, you know, competition. People make stuff better. I see that, that works good. I think I could make a much better one, and they usually do. So that's why you got to keep thinking about how to make it better, whether it's something you design or your business or your software, or whatever it is. So the kids constantly make stuff better. They'll make the first time, the first pass, and then the next time Michelle sends me the thing to print, or I take a look at what they did, it's like, wow, look at that. They added this and they added this and they added this. So they're constantly trying to improve things, which is something that if the kids can figure that out on their own, and of course, you know, either her or me has to say, great job, you know, and let them know. That's the other thing. You have to feed back to the student positive information about the things that are incredible, that most, you know, a lot of people just don't realize how incredible it is. You know, people use their fingers all the time. They don't realize actually a miracle from God. There's no robots that can do this. You can see robots that look like they can do it. There's no robots that can do that. Think about getting out of your car. You've got a cup of coffee. You got the stuff you got in the store. You got a bag full of stuff, right? You've got paperwork. You stick it in your pocket, this and that. Somehow or other, you get your leg over the side of the car. You get out. You're holding all this crap. Oh, God, I forgot my phone. You put your phone in your pocket, right? And you somehow or other get your way out of the car carrying all that stuff. There's no robots that can do that. You know, that's just a gift from God. So anyway, what I wanted you to, you can play around with the stuff. The dinosaurs love to be held. The one thing that I didn't mention about 3D printing that is really important is that, and I left it to last on purpose, but 3D printing is printed in layers. So it's kind of like a hot melt glue gun, except instead of glue, it's plastic. It goes back and forth this way and this way, right? So, and then the build plate goes down, which gives you your third dimension, and it prints one layer on top of another. That's the only way you can make interlocking parts. Is because when the printer is printing the two parts that interlock, it doesn't even know the other part is there. It prints this part and this part at the same time. And as it develops the parts, they automatically get interlocked because it's printing them both in layers. So that's the only way you can have those parts interlocked. So what I did for you guys is you see these two QR codes up at the top. If your phone recognizes the QR code, this will take you to my website, fairdealdave.com. And this will take you to this one here will take you to a cloud, it's a cloud server that I set up. And I made a folder there with videos that explain all of this stuff. It was what I was actually going to do at the last meeting, but then I thought I'd rather talk about the program. And you can watch that because it's better to watch it on your own. You can stop, you can go back, you can go forward. But there's two videos there. One that shows how to take a cube that's solid and put a hole in the middle with Tinkercad. And the other one just shows you how to take, oh gosh, I forgot I glued this one together. This doesn't really belong here. It's how to take this bottom part of this note card holder, how I actually designed it. So I basically take it apart in Tinkercad so you can see how all the parts were designed. So that's another thing that you can do is you can, so this clock, no one knows I love clocks. My company name was Time Frame. We started out making clocks, which didn't turn out to be very profitable, but that's another thing I learned the hard way. So this is the only part of this clock. This and this hand is the only part that was actually purchased. So the dial was completely 3D printed. You can 3D print in color, but you can't have the colors change within the layer. But you can change on the better printers. You can change. You can tell a printer at this layer, stop. I'm going to change color, and then from there on, we're going to go in red or blue or whatever, right? So that's how you can get different colors. This part, I just started measuring this, and I figured I've got to get some way to keep this, and then I need to make a stand. So the stand and this holder. So I did the holder first. And came up with the holder and then decided how that was going to fit in the stand, and it all fits together. And this is just a promotional item for the FLCCC, and this is the note card holder for the same thing. And I designed the note card holder so these can be pulled out, and if your business decides to change its name, You can just slide in a new one. So you can't do that with the clock too easily. But anyway, those are the things. Go ahead and take, you can take one of these on your way out and take one of these if you will.
Thank you very much.
And that's it.
So outdated. My grandson knows more about it than I do.
The ones that I have, I check the clock is recommendation.